Hello everyone. So we are back with Leetcode daily challenge. In today's problem, we are going to solve count servers that communicate. Right. So in this problem, we are given a map of server centers represented by m into n integer matrix called grid, where 1 denotes that there is a server in that place and 0 means there is no server. Two servers are said to communicate if they are on the same row or same column. So we need to return the number of servers that can communicate with any other server, right? So for example, if we take this example, here we are given a matrix where 1 0 and like here this is one server and this is another server. They can't communicate, right? So the answer is 0. And in this example, this first server can communicate with the second one, and this second server can also communicate with first and third one, and the third one can communicate with the second one. So one thing to keep in mind that here we are not asked to return all the possible ways in which a two server can communicate. We just need to check whether a server can communicate with any other server or not. So for example, here the answer will be 3 in this example, not all the possible ways in which the three servers can communicate with each other, right? So here the first one can communicate, the second one can communicate, and the third one can communicate, right? So the answer is 3. Now moving back to this example, here the first one can communicate with the second one. Similarly, the second one can communicate with the first one. This one can communicate with the lower one, and the lower one can communicate with the upper one, but this last server cannot communicate with any of the other server. So the answer will be 4, because there are only 4 valid servers which can communicate with any other server. So the constraints are m can be up to 250 and n can also be up to 250. So what is, like, let's discuss what can be the brute approach, right? Brute force approach. So we will move back to our notepad. So for example, like what it is given, for example, I am having like two servers, and one is here 0 0, yeah. So here for example, this one is server. There are three servers here, and 3 empty places. So what can be the brute approach, right? The brute approach can be like, for example, we will traverse through the matrix, like we do row wise and column wise. So what will be there, we will traverse through the matrix and check if like we got any server. If it is a server, if the cell is a server, then what we will do, we will check the row check and column check. Yeah, so when we will check the row for that server and also the column check, if we found any server, if server found, then what we will do, we will increment the answer, we will count this server into our result. So answer will be plus equal to 1, right? So this will be brute force approach. For example, we will traverse through the matrix. So for example, we counter a server, this is a server, we will then check the rows, there is a server, yeah, we got a server. Then we can also break the statement there only, we got the server in row only, then we will return, like we will increment the answer to plus 1. For example, if we not found the server on any another server in this row, then what we'll do, we'll check the column also. If we found a server, then we will add that to answer, else we can skip that server. Then similarly, we will move to the next one. There is an empty space, we can skip this place. Then we got another server. Similarly, we'll check the row and column for that server. In this way, what we can do, we can check for each row and column for each of the server nodes, and we can return the answer. So let's discuss about what will be the time complexity for this approach. So for example, if we are traversing the matrix, then there will be 2 for loops for row, like the ith loop, and there will be for jth loop, which will be for the column. So there will be by default any square matrix traversal. And what we need to do, we need to we need to check the row and column, right? So for example, if we got a server, then we need to check the row, and then we need to check the column. So the row and column check will be completely independent, so it can be at max take n time complexity. So as a whole, like overall what time complexity we are getting n to the power 3, right? So if you are having n at to the power max 250, then the 3 will be 250 to the power 3 will be much larger, so that will give a time limit exceeded error. So somehow we need to like optimize this solution, and we need to we can like move to n square solution that will be accepted, right? So let's discuss about the optimal approach. So one approach I got in my mind initially is to check each row and each column, right? So what the approach was like, I will check each row and each column, and if any row or column have more than two servers, then I will return, like I will increment the answer to the total number of servers in that row or column. So what, like if I'm talking about the example, like I'm moving back to my terminal. For example, there is one server, I'm denoting as server, o server, right? So what I will do, I will like try to iterate over the rows and columns. So I will go through the first row. So in the first row I got only one server, right? So when I'm traversing through row, I got only one server. So yeah, it is not greater than 2, so we'll not add that server to our answer list. But in the second row, what I got like two servers, and that is greater than equals to the value 2. So we will, what we will do, we will increment the answer plus equals to 2, right? So these two servers will be considered when we traverse through the second row. We can also check the same for the column wise. So for first column the answer will be 1 when we will traversing through the column. For the second column we are getting answer 1, and for the third column we are getting answer 1. So that three cases will not be considered, only this row traversal will be considered, and our answer will be 2, right? But there is a catch in this approach. This is not correct, because what we will do, like what will give wrong result when there is a common node for each row and column. For example, this 0, like this middle 0, this is a server, right? So what this approach will give wrong results. In the first row we are getting two servers, in the second row we are getting two servers, and also when we are traversing the column wise, then we are also getting the two servers, right? So there is a like intersection between the servers, so that will not give correct result, because this intersection will not be handled in that approach, right? So that thing to keep in mind. Yeah, so now we will move to the correct solution, the correct approach, and what is the optimal approach here. So what we can do, for example, we are having a server here, server node. So what we can do, we will traverse through the matrix, traverse, and what we'll do, we will check whether it is a server or not, it is a server or not. If it is a server, then we will do two things. One, to give an information about whether that row or column have a server or not, right? So we will make a like a vector or any set kind of thing. So for that row we will increment the counter, like for that row whether that have a server or not, right? So also if that column, if there is a server, the column will also be incremented to +1, because that column has a server, right? Similarly, that will be done. The another thing we will doing, we will be storing that server node to our like any other data structure, and we will later traverse only the servers part, right? So what we will do, we will make a, like a any data structure, and we will push that server ith row and jth column to that data structure, right? So later on when we finish our traversal, what we will get, yeah. So yeah, so later on what we will get, we will get a list of servers, right? List of servers, and row information, like whether that row is having a server or not, and a column information, whether that column is having a server or not. So what we will do, we will iterate over that list, we'll iterate over the list and check whether the like the row or column, whether any one of that row of that server or column of that server contains greater than equals to two servers in that row, in that row or greater than equals to 2 servers in that column, any one, or this will be a or, not a and, right? So we will iterate through the list of servers and we will check whether the row of that server contain greater than two servers, and whether the column of that server can contain greater than two servers. In this way we can easily solve this problem. Now let's discuss about the time complexity. So what we are doing, we are traversing the matrix, so that is normal n square part, and later we are traversing the servers, right? We are traversing the servers, so the maximum time complexity of traversing the servers can be n square, because in the matrix for m into n there can be like m into n servers at max, right? So this is the approach, and we are getting a time complexity of n square overall. And what is the space complexity here? We are only storing a like any data structure to push the server nodes, that can take a maximum of n square time, n square space complexity. Yeah. So the space is n square, and the time time complexity and n square. So 2 to the 250 to the power square will not be much greater, right? So now let's try to solve this problem. We are going to implement the solution we have discussed. So initially we will take the rows, like size of the grid n. Yeah, so this is m. We will take the n and will be grid of 0th index size. Yeah. Now what we will doing, we will traversing through the matrix. So for int I equals to 0, I less than m, I plus plus, for int j equals to 0, j less than n, j plus plus. What we will doing, we will check if we are getting a server or not. So whether grid of I comma j is equals to 1, because 1 denotes a server. So what we are going to do, we are pushing that server node to a data structure. So what we can do, we are going to take a vector of pair of int comma int. So pair will be for row and column index, right? So pair of int comma int. So I am denoting this is as for server, and we are storing that server node to that data structure vector. So we are pushing back the ith index comma jth index, right? Now what we will do, we will also keep the information whether that row or column have a server or not. So for that we are also taking a vector of int, and I will call it as row, and then I am taking the size as m, and the by default value will be 0. Similarly we are taking a vector of int as column, and the size will be by default n, and the default value will be 0. So what we are storing, if we are having a server in that ith and jth row, ith row and jth column, then what we are doing, we can keep the row of increment the row of I plus plus, so it will be plus equals to 1. Now also we are incrementing the column value plus equals to 1, right? So these are the operation we are doing while traversing the matrix. So once we have completed traversing the matrix, what we gonna do, we gonna iterate over the list of the servers, right? So what we'll do, for auto it of s is the server here. So it will be a pair, because we have taken a vector of pair, so it will be a pair. So we can get the row of that server from int r equals to it dot first, and we can go get the column of that server from it dot second, right? So we got the row and column. Now what we need to check, we need to check whether that row, row of that server contains more than two servers or not. More than, greater than, equals to two server, it can be two servers also. So what we will check, we will check the row of r is greater than equals to 2, or there will be or statement. So if column of c is greater than equals to 2, so if any of the row or column contains two or more servers, then that server can communicate with the other server. So we will take another variable answer, int answer. Initially it will be set to 0, and now if this check will pass, then what we'll do, we will answer plus equals to 1, right? So this is our solution. At last, after traversing, we will return the answer. So let's try to run it first. Yeah, so it works fine. Now let's try to submit it. Yeah, so we have solved this problem. It was an easy problem, and it was a kind of variation of old problem only, 2 days before what I have solved after a year problem. So yeah, that's it. Thank you. Have a nice day.